All right, AP 20.2, balancing oxidation reduction equations. It's going to be a completely new ball game that you've never seen before. So right here represent a balanced redox reaction, and it's these new things called half reactions. You haven't seen one of these before, okay? So balancing a chemical equation for redox in these half reactions, and as I said right there, the terms for oxidation, oxidizing agent, reducing agent, not on the AP test. Just like the word oxidant, A-N-T at the end, reductant, not on the AP test. You do have to know just oxidized, reduced, okay? So recall, ladies and gentlemen, the law that started it all back from 2 years ago, the law of conservation of mass, that the amount of mass in the beginning has to be the amount of mass at the end. Well, we actually have many laws of conservation. The law of conservation of matter, of energy, okay, which you saw right there, first law of thermodynamics, okay, aka chapter 5, okay. Well, now we have a law of conservation of charge, and it has to do with the electrons. You cannot have different electrons in the equations and it doesn't balance out, because look at your balance equation. This is your overall balance equation, and I don't see any electrons listed in here whatsoever, okay. So then where'd the electrons go? Well, that's where what's called half reactions come in. We take two halves and make a whole. So what we call the overall balance chemical equation, okay? So law of conservation of charge is keeping track of where the electrons go. So gaining and losing electrons, they have to be balanced. It has to. And electrons lost by oxidation, they have to be gained by the reduction. And that's a bad spelling error right there. Oops. That's why I'm definitely this summer editing my notes big time. Redox half reactions. It's a convenient way to separating the equation that was oxidized and the equation that was reduced. So you're going to actually see two equations here, okay? So the overall balance equation is magnesium reacts with some oxygen, and obviously there should be some states of matters. Come on, Rodriguez. States of matters right here, and definitely would be a solid. Would not be aqueous, ladies and gentlemen. You didn't put it in water, okay? You took a solid and burned it and made a solid, okay? So magnesium oxide, and actually you did this lab in CP and honors where you took a strip of magnesium metal, we put it in the flame. You saw the big black, big flash white light where I said, don't look into the light, don't go into the light. That was that lab, okay? So the half reactions is where we split the equation apart. We look at how magnesium went from one to another. So we say magnesium went to the ion, okay? Because remember right here, this is +2 and -2. And then we say the oxygen, O2, went to the -2, okay? Well, I'm going to do this work right here so you understand where this part came in, okay? And there should be a charge right there. I think it got cut off. So the magnesium, let me do it right here. So the magnesium went to Mg +2. But the law of conservation of charges says that the charges have to equal both sides. You didn't lose or gain, they just got rearranged. Well, if you notice, this side has an overall charge of 0. Well, this side has an overall charge of +2. So I'm saying overall charge. I need this right side, I need it to say 0, so that way they can be balanced. Well, where did they go? You got to remember, this was protons equal to electrons, and this magnesium lost electrons. So where did it go? Well, he lost them. And he not only lost an electron, but he lost 2 of them. So you got to remember, ladies and gentlemen, an electron particle, it is a -1. And if I put this coefficient in front of it, it's like if I would have said electron plus electron. I have 2 of them. Well, that 2 times that -1, that equals -2. And there, ladies and gentlemen, there's my 0, as you see right there. And this is what's called the oxidation half reaction. And how did you know it was oxidation? Because magnesium lost electrons. How else did you know? the oxidation number increased. So this is what's called an oxidation half reaction. Okay, so now where's the reduction half reaction? Well, let's take the same thing for oxygen. We have, you literally break the equation apart. That's what you have to do first. You have to break it apart, unless they already had it broken for you. This elemental form, oxygen gas, has an overall charge of 0. And then goes the oxygen, -2. Well, it was perfect. Protons equal to electrons. But now, this oxygen gained not only electrons, but gained 2 electrons. And how do you know? Because look at the number. Okay, 0, -2. Okay, you were 0 and it went down. The oxidation number decreased. Okay, I went from 0 to -2. And I know you're like, well, Rodriguez, it's 0, then 2. No, it's -2. Okay, you went down. You went below 0. Okay, the oxidation number went down. So where do I balance my electrons? Okay, well, first thing is, ladies and gentlemen, you got to remember basic balancing. Okay, you need to make sure that you balance the elements first. Okay, you have to balance elements first. Let's go look right here. I got 2 oxygens over here. I only have 1, but it has a -2 charge, but I still only have 1. So I need to put a 2 there, so that way I have 2 on each side. And then step number 2, you balance the electrons. You balance, aka the charges, because we need the charges to equal both sides. Well, right here I have a 0. By putting this 2 right here times this -2, I have an overall charge now of -4. So what do I need? I need this side -4. If I add electrons over here, I'm just making it more negative. Well, I don't want to add the electrons over there. I want to add the electrons to the other side, because if I add an electron, there it is. Now I have a -1, but I need it to equal -4. So I got to put 4 electrons over here. Okay. So far, hopefully so good. And you're like, I got it, Rodriguez, but give me some more examples. You know I will. The oxidation number shows the loss of electrons. Reduction half reaction shows the electrons that are gained. But here's where it comes together. When you put not only star, but box that bad boy, heck, even highlight it. If you add 2 half reactions together, the law says that the number of electrons lost has to equal the number of electrons gained. I don't see in my overall balanced equation, I don't see any electrons. So where the heck did they go when I put these 2 equations together? Well, let me kind of clean it up here. So I have magnesium plus 2 and 2 electrons. Sorry, should not be a plus sign there. Arrow. And you want to line up the arrows. So for oxygen, I had 4 electrons plus O2. And when you're doing this work, ladies and gentlemen, notice I didn't write any states of matters here because it's called doing the half reaction works. It's kind of like when you did like Hess's law, when you flipped equations and did all that stuff. It's just called your work. Your final equation needs to have those states of matters. So the name of the game is when I put these 2 equations together, literally just add the equations, the 2 half reactions together. These electrons have to cancel. So this is when you think of, how can I get them to cancel? Can I multiply any equation by a number so that way I can change maybe these 2 electrons to like a 4? I can't change this 4 and to make it smaller. Okay, I can only add 2 electrons. Can't take them away because then the charges won't equal each other. So what you do is you multiply this whole equation by 2. Okay, and usually what you would do is put a 2 and then put parentheses around it. And by doing that, now I have a 2 here. I have a 2 here, and this now changes to 4. Don't erase it. Just cross it out, right over it. That's fine. And now, ladies and gentlemen, my electrons, they can cancel. Okay? My electrons can cancel because think of it kind of like an intermediate. Okay? It was produced in one step, maybe consumed in another, but it's not an intermediate, a true intermediate, because this is a particle. It's not a chemical. Okay, I'm just telling you, think of it kind of like an intermediate as in crossing out. And now everything comes together, what's left over. So I have this 2 magnesium solid, and it reacts with that oxygen gas, and then I get 2 Mg plus 2, and then I get this 2 oxygen negative 2. Well, look at that product right there, ladies and gentlemen. Mg and O, they came together and made a bond called 2MgO. Oops, did I put a 2 too many places? Oops, I put a 2. Oops, this 2 right here should not be there. No 2 right there. No 2 right there either. Okay, too many 2's, too many 2's. Okay, and there it is, ladies and gentlemen. That's the overall equation, but these are the half reactions. And what you'll notice is that every time you have oxidation reduction, the electrons, they always appear on one side of the equation. So for oxidation, the electrons always appear on the product side. Because, ladies and gentlemen, you didn't produce them, you lost electrons. Okay, you didn't produce them, you lost them. You got magnesium, and now these electrons just flying away. And with reduction, you'll notice that the electrons will appear, and you'll see this in my notes in the next video, appear on the reactant side. Because I gained electrons with that oxygen. Okay, so these right here, very, very important. As you'll see it in the notes in 20.3. Okay, so let's do a little bit of something like this. What if you had this example where you had an Fe plus 3, Fe plus 2, so this is one half reaction, and I have 10, and then I want to bring them together to make an overall balanced equation. Okay, so I have a plus 3, plus 2. First step is balance the elements. Okay, I got one of each. Sweet. And now add electrons. Well, if I add electrons on this side, I got a plus 2, minus 1, because you've got to think of that as minus 1. I'm just going to make this plus 1. Well, that's not going to help. So I need to put the electron on the other side. And now when I add a negative 1 plus 3, now I have my plus 2, they now equal each other. On this half reaction, I know the electrons cannot be over here because the electrons, when you bring them together, they can't both be reduction. And because it's electrons on the side, this right here, iron went from plus 3, already having 3 missing, and now plus 2. He gained an electron. And because he gained an electron, you see reduction. The electrons appear on the product side. I'm sorry, the reactant side. And AP is totally fine with that explanation. The electrons appear on the reactant side. Done, sweet. The oxidation number went down. The oxidation number decreased. The reaction gained an electron. All of those are perfectly fine explanations, ladies and gentlemen. There's not one. You can put 3 different type of explanations for the same thing. So now for 10, I know I have to have electrons on this side because they're going to have to cancel out eventually. So if I only put 1, remember I need this to say plus 2, and I need this side to also say plus 2. Right now it only says plus 3. So I need 2 electrons. So plus 4, remember this 2 goes for the electron, negative 2. And so plus 4 minus 2, there's my 2. Now if I'm going to bring these 2 equations together, I need these to cancel. So I'm going to have to multiply that equation by 2. And when I do that, this will have a 2, that'll have a 2, and that'll have a 2. I usually, when I'm doing these practice problems, like if I was doing it in front of you, I love to bring out the colors. Pencil, pen is all you get on the AP test, and that's fine. Use a pencil and a pen. But right there, it's kind of like my way of saying, okay, I added that 2 in, and I only added that 2 in because I need these to cancel. And now I bring everything together, and I get 2Fe and aqueous. Final equation's got to have that states it matters. 10 plus 2, and a whole bunch of aqueous. And 10 plus 4, I always get the question from students. Does it matter which order you put them in? Nope. Alphabetical. Your favorite element first. Whatever floats your boat, ladies and gentlemen, just as long as you have the right chemicals on the right side. And this is when Rodriguez is yelling at you. Think of it like your sig figs yelling at you. Check your work. And what I mean by that, check the law of conservation of charges. Make sure, hello, what's my pen doing? That's crazy. Okay, make sure you check the law of conservation of charges. Now check it out. Let me do it like in a different color. I have 2 times the 3. I have a plus 6 here. I have a plus 2. So right now I'm looking at plus 8. And I have this plus 4 here. And 2 times that plus 2, plus 4. It's got to equal both sides, ladies and gentlemen. So please do not lose the easiest points on the AP test because you forgot to check your work. Okay? Let's do another one. Okay? So this one's a little bit more complex. This is what we're going to be getting into. So let's say I have this half reaction and this half reaction, okay, right here. And let's see what I need. Okay, well, I have an overall charge. I have an overall charge of, oops, let me get -1. I have an overall charge as 4 times plus 1. I have an overall charge of plus 4. I don't see any charge here. And if you don't see a charge, then it's 0. And if I don't see a charge here, then it's 0. I'm not trying to determine who is oxidized and reduced. I'm trying to figure out, is this equation an oxidation or a reduction equation? So same thing right here. This was reduced because the electrons were on the reactant side. Over here, this one was oxidized because the electrons appear on the product side. I'm trying to figure out which equation, okay, not who is oxidized and reduced, which equation is oxidation and reduction. So I have a -1 and I have a total charge of 0. Right here, I have a total charge of plus 3. I need it to equal 0 because if I add electrons over here, I'm going to make it negative. So I can't add it to that side. So I'm going to have to add electrons over here. And how many to get this to be 0? I'm going to have to add 3. And now I'll get -3. Okay? Down here, okay, so wait, hold on. So let me ask you a question. Is this half equation, okay, so we're calling this the half reaction. Is this half reaction an oxidation reaction, or is this a reduction reaction? See where the electrons are on the reactant side? This is a reduction, half reaction. Okay, it's an equation, half reaction, reduction. And this one right here, look at every chemical, what the charge of the chemical is, not the substance, the charge. So this water, I don't see a charge, 0. This compound right here, I don't see. So far I got a 0 for the reactants. Don't see any charge here. But I do see a 4 times plus 1. I see a plus 4. So in this case, ladies and gentlemen, I have right now plus 4, and I need it to say 0. I got to add electrons over here, and I got to have 4 of them to get that -4 charge. Okay? So this is the complicated part. What if I have a 4 versus a 3? And because this 4, the electrons are appearing on the product side, this half reaction is an oxidation half reaction. Sorry, I don't want to cram that in there because I don't want you to think I'm writing the word oxidized. Oxidation half reaction. Okay? Now, basic elementary math. Something called a common multiple, and the lowest common multiple. So if by chance you have to affect, so if the electrons for both half reactions, okay, basically one's not, if this would have been a 2 electrons versus 4, well then I could just multiply this whole equation by 2. But what if it's not going to work like that? I can't just add an electron. It doesn't work like that. So if the electrons both in the half reactions, how can I say it, not easily seen to cancel, then what happens is something called, back in the day, least common multiple. I need to find a common multiple between the 2 of them so I can cancel it out. So you're thinking like a 3 versus a 2, and what I would have to do, or sorry, 3 versus a 4. What is the common multiple that if I multiply it out, so if I pick 2 for each side, Well, then right there I got a 6, 6, and an 8. Well, it's still not going to be balanced. If I pick a 3, well, that's 9. And 3 right here, oops, hello, that's 12. But if I do go, maybe this one, if I multiply this one by 4, I can get 12. So basically, ladies and gentlemen, I'm sure you saw it, but you're trying to figure out a common multiple between the two, and the least common multiple would be if I multiply this whole equation by 4, and if I multiply this whole equation by 3. If you would have seen, I've seen equations where it's like a 5 versus a 4. The least common multiple is 20. These are the type of topics where you see these big coefficients, like in the 20s, in the teens. These are the big coefficients. And don't freak out, it's okay. So if I multiply this whole equation by 4, I got to tell EP and I got to show them how I did that. So that's why a different color helps. So I got to change this. So it's like saying multiply this whole thing by 4. And this right here is going to change to a 12. And this is now going to be a 4. That 4 times 4 is going to be 16, and keep very key track of all these numbers that I'm writing in this different color. That's going to be 4, and then 4 times 2, that's going to be 8. This whole equation, I'm going to multiply everything by 3. So 3 times 5, just cross it out, put a 15. 3 times 1 is 3. 3 times 2, 6. 3 times 4, 12. And then 3 times the 4, also 12. And that's how, ladies and gentlemen, the law of conservation. I can now cancel those electrons. And the name of the game now is put it all together. Okay? So here's another thing. If the same chemical, the same compound, substance, probably the word substance would be better because I don't want to say compound, because it could be an ion too. If the same substance, so I'm going to put the word compound or molecule or ions appear, let's scroll up some, appear in both half reactions, okay? You can either cancel some or add them up. If on the same side of the equation, and cancel some if on opposite sides. And where am I trying to get at? Look at those H pluses, okay? Right here. Look at these H pluses right here. I have 16 of them. And look on the opposite side of the arrow. Keep track of that arrow. On the opposite side, I have 12. Well, ladies and gentlemen, you cannot have the same chemical on both sides of the equation when you add this all up. Overall, find an equation. They can't. It's like when you guys back in chapter 4 would have water on one side and then water on the other side. No, don't do that. It's ghetto. So I can cancel out some of these. So what happens is this right here, let's go orange. I can cancel 12 of those and change this 16 now to a 4, okay? So I can cancel all 12 and then just change that 16 to a 4. Well, now I know I have definitely 4 H pluses. Aqueous. Let's see if there's anything else. This NO3, I don't see him anywhere else, so I'm going to put this 4NO3 in here. Aqueous. Okay. This NO, I don't see it anywhere, so I'm going to put this 4NO over here, and that's probably a gas. And let's check out these waters. Now look at these waters over here. Let's go a little purple. I got 8 waters here, but on the other side I got 15. Now what I can do is cancel 8 of those and then change this 15 to a 7. If you need to use a calculator, go ahead. Okay, so I'm definitely going to have 7 waters on this side. Water, ladies and gentlemen, liquid, okay, unless they wanted a gas. Let's see what else. I still have this arsenic compound, so I have 3 arsenic, O3, and I don't know what that state of matter is, gas, solid, I'd have to actually look it up. And then I have this, looks like an acid over here, so 6H3ASO4. That is an acid, so I'm going to say aqueous. Even though it's a weak acid, it's still going to say aqueous. So let's double check we got everything. I got, do a little check mark here. Let's go a little black right there. Okay, let's go a little purple. Okay, I got my 4NO3 right there, -1. I got my 4 H pluses, check. I got my 4 NOs, okay. We already canceled out 8 of those waters, and I got 7 waters left, check. My 3 arsenic molecule, my 6 acid, and everything else is gone. So the final equation, ladies and gentlemen, notice no electrons in that final overall equation. Only electrons can appear in the half reaction. But I know you guys are good boys and girls, would never disappoint Rodriguez, and you would double check basic balancing. Let's check it out. So let's make a little thing over here. Arsenic. I have 6 arsenics on this side. Oxygens right here. I have 9 plus the 7 from water plus the 4 times 3. Okay, so what is that for oxygen? Oh my gosh, it's too early for do math right now. So 16 plus 12, so that equals a total of 28. Hydrogen wise, I have the 14 from water, and I have the 4 from the hydrogen. Okay, so that right there, there's 18. Let's check this side. Oh, I need to put my nitrogen. I was like, hello, I know there's another one. 4 times the nitrogen, so that's just 4. So now the product side. I have 4 nitrogens. I have 4 oxygens here, plus oxygen, 6 times the 4, so 28. All right, everything's looking pretty good. Oh, wait, no, 4 times 3. Hello. 4. Woo! Okay, it's a Sunday morning early. Okay, 6 times 4 is 24. There's my 28. My arsenic, I do have 6 of them. And my hydrogen, I do have 6 times 3. Ta-da, ladies and gentlemen, it's balanced. But what you're going to check is the charges. Make sure you haven't forgotten to check the charges. This is neutral. Neutral. 4 times 3, 4, I'm sorry, 4 times -1, -4. And then 4 times this plus 1, so 4 times -1 is -4. And, sorry, let me make sure I'm saying this correctly. 4 times -1 is -4. And 4 times plus 1 is +4. There's my 0. I don't see any charges. I don't see any charges. Ta-da! It takes a minute, ladies and gentlemen, but come on. We cannot miss the easiest points called balancing an equation, okay? So hopefully you got a little fun out of that. You're like, wow, Rodriguez, I thought balancing equations were so easy. They are, but you just got to do a little bit of work now, okay? And this is the part that just brings tears to my eyes. AP cut this. You do not have to do any balancing equations for what's called acidic solutions and for basics. And it just breaks my heart. So unfortunately, because we are literally less than 4 weeks away, ladies and gentlemen, I cannot be teaching topics that are on not on AP test. But I'm not going to lie to you. This is the topic that deepened the love for chemistry. So when you get to college and have to take chemistry and you get to electrochem, give me a call, give me an email, because you know I'll still be at FOHI with Fisher. We'll be there forever, and I can always help you with this, okay? So unfortunately, ladies and gentlemen, no notes to up.